You're signed into the GSE conference 2021, and this is the enterprise security stream. If you're in the wrong stream, now's the time to change. Okay. The eagle-eyed amongst you will notice that I'm not Jamie Pease, who usually presents these sessions. I'm Lenny Bradshaw. I'm standing in for Jamie. This morning we have a session from Gwydion Tudor on securing MQ channels. This is session 1AT. There is a feedback request in all of the agenda items, so I'd ask you to make use of that. This session is being recorded and will be available at a later time, sometime after the conference. I think Gwydion is quite happy to take questions during the session, but please will you submit the questions in the chat. If we need to unmute you to get you to talk, then we can do that as well. I think if that's all, then we'll probably hand over to Gwydion. As I've said to Gwydion, I'm not a specialist in MQ at all, but I'm sure that many of you have experience with using MQ and would like to know exactly how to secure those channels. So, if there's nothing else, I'll hand over to Gwydion.
Okay, thank you very much. So as Lenny said, my name is Gwydion Tudor. I work in the MQ development team, normally based at IBM Hursley, but these days we're all still working from home. So I'm happy to take questions at any point. I'm not going to go into great details in introducing what MQ is and what MQ channels are. So if you have any questions about that, if I've sort of assumed some knowledge that you don't have, then please ask and I will explain anything that I've said. Right, so let's get on with it. Of course, please consider making a donation to the GSE charity. And for that, what we're going to talk about is securing your channels in MQ. So we'll first of all look at a bit of an introduction of security in MQ and then zoom in on what we're actually going to talk about in more details in this session, which is TLS on MQ channels. So we'll look at how you configure that, and both for encryption and authentication. We'll look at some of the recent enhancements that we've made in MQ with regards to using TLS on your channels, and also AT-TLS on ZOS, which is something that you can use with your MQ queue managers on ZOS. So let's start off with a introduction to where you have security, essentially where you need to consider security in your MQ estate. There's many places where you need to consider security and many reasons that you need to do so. So for example, you have authentication that you need to consider, and that's for client channels that are coming into your queue manager. So that's applications that are connecting in over the network to your queue manager. You also need to authenticate those connections to make sure that you know who is connecting and they're actually allowed to do so. And the same is true for connections between queue managers. So when a queue manager to queue manager channel connects into a specific queue manager, then you want to make sure that you know who is at the other end and that they're actually allowed to connect. Same is true for local applications that are using local bindings to your queue manager. And also recently, we've added, well, fairly recently, we've added new interfaces so you can manage MQ using HTTP. So there's an MQ console, which is a web-based application that runs in a Liberty server, and also there's a REST API. And for both of those, I would say you need to do a level of authentication actually in the Liberty server for whoever's logging into the console and the REST API. You also need to consider then authorization. So that's checking that the user is allowed to access resources in MQ, which would be queues, for example, when an application tries to open a queue to do some messaging. And you've also got authorization for administrative actions. So, for example, defining a queue. You also obviously need to consider auditing, so making sure that you have a record of what has changed on the queue manager and who made any changes. And the other thing that you might want to consider is using message level protection. So MQ or AMS actually is the component of MQ that will let you protect messages individually by encrypting them so that only the intended recipient of the message can see it, and also potentially signing them so that you can be sure that they haven't been altered at all between the time that they were put into MQ and when they were got by the application that's actually intended to get them. So that's an overview of all the bits of MQ that have security built into them and all the considerations that you need to take into account in your MQ estate. We're not going to take a look at all of those today. The bits that we're going to take a look at today are the channels between queue managers and between applications and a queue manager, and how to secure those channels. And of course, the way that you do this is by using TLS, which is a fairly common way of protecting connections over the network these days. So I'm not going to go into great depth to introduce what TLS is. I'm going to assume that you already know a bit about what it does. I'll highlight the advantages and why you might want to use it with MQ here. So of course, TLS provides encryption of data. So it will encrypt data between endpoints, so that that's either a queue manager to a queue manager or an MQ client to an MQ queue manager, to prevent anyone who's able to view the data on the network from actually being able to view your MQ data. And also TLS provides integrity protection. So it lets you be sure that the data hasn't been changed while it's on the network. So those are actually the same qualities that you can get by using message level protection using AMS with MQ. So if those are the only reasons that you're using TLS on your channels between your endpoints, particularly queue manager, then you might want to consider using AMS, because the performance of it is pretty similar, and it also gives you additional benefits in that it protects the messages when they're at rest on the queues as well. However, people often use TLS as well for authentication, and that's something that TLS is able to provide by using digital certificates. So you will need a digital certificate for each endpoint, and those certificates will get swapped during the TLS handshake, and the endpoints will check that they are trusted to ensure that the connection is authenticated, then we know who is connecting into your queue manager. And the good news is that TLS has been supported natively in MQ for many years now, so you don't need to install any additional bits in order to get TLS on your MQ channels. Let's look a little bit in more detail about how you turn on TLS on your MQ channels now. Now, there is an attribute when you define your channels, which is called SSL Cipher, and this is essentially the switch that turns on TLS on your MQ channels. And what you specify in that attribute is the cipher spec that you want to use on that channel. We'll have a look at the cipher specs in a bit more details in a few slides. For a number of years, you needed to specify exactly the same cipher on both ends of the channel, because obviously both ends need to agree on which algorithm is being used to encrypt the data, for example, so they can be decrypted at the other end. That has changed slightly in the last release or so of MQ, so we'll look at those enhancements a little bit later in the session. Of course, the other thing that you need to do, as well as specifying a cipher for each end of the channel, is to also have some certificates. So you need a certificate for each end of the connection, and you need to store those certificates in some kind of key store that MQ can access. So on ZOS, there's going to be a RACF keyring or an equivalent from another security provider, or on distributed, that's going to be a CMS key store that you create using one of the commands as applied with MQ. So let's look at the cipher specs that you can use in MQ in a little bit more detail. So an MQ cipher spec gives a lot of information about what protocol and what algorithms are going to be used to secure the connection. So it specifies the protocol level, which will be SSL or different versions of TLS, the algorithm that's going to be used to actually encrypt the data. I think the key exchange algorithm is in there as well, and you've got the key size as well. So there's a number of things that are all specified by the Cipher spec, and you've got some examples here of Cipher specs. I wouldn't actually encourage you to use a lot of the ones that are on this slide, because a lot of them use protocols or algorithms that are now a little bit old and insecure. So don't take this list as a recommended list of ones to use. It's just an example that's been picked up from the documentation, just to show you the table that we have in the documentation that shows you exactly which protocol and which algorithms and the strength of those algorithms that are going to be used for each particular Cipher spec. And the point here is that although the Cipher spec name gives you many clues about what protocol and what algorithms are going to be used, you should be checking the MQ documentation to see exactly what a given Cipher spec is going to give you in terms of the protocol and the algorithm. You're all probably aware that over the past couple of years, we've had a number of vulnerabilities that have been pretty public, and as a result of that, a number of protocols and a number of Cipher specs, because of the algorithms that they use, are now considered insecure. And MQ has had to deprecate a number of Cipher specs because of this. So we have now quite a number of deprecated Cipher specs in MQ, and those are not enabled by default these days in the queue manager. You can re-enable those Cipher specs, but you do need to take explicit action to do that. There's a couple of ways of doing that. We'll look at one later. There's also an environment variable that you can set to explicitly re-enable certain Cipher specs. So the algorithms that are used and specified in the Cipher specs give you mostly the encryption and the integrity protection of TLS, but of course you also might well want to use TLS for authentication, and for that you need digital certificates, and you need to be checking those digital certificates at each end in order for each end of the connection to authenticate each other. So with TLS, the client will always ask for the server certificates when it connects. The client in this case can be an MQ client, or it can be a queue manager that's connecting to another queue manager, and the server of course is in this case going to be a queue manager. So the queue manager needs to have a private certificate, a certificate that is associated with a private key. That will be in its key store, whether that's a RACF keyring or a CMS key store on distributed. And that will be provided to the client when the client connects to the queue manager using TLS. And similarly, the client, if it's configured with a certificate, can provide that certificate to the queue manager when it connects, and that will allow the queue manager to authenticate who the client is that's connecting in because of the certificate that's provided during the TLS handshake. Now, there is an option on your channel definition called SSL-C auth, and in the example here, we've got it set to required. What that says is that the queue manager requires the client, when it connects in on this channel, to provide a digital certificate to identify itself. And the queue manager will then check that that certificate is trusted, and it'll be trusted if it's either actually been exported and imported into the queue manager's key store, or probably more commonly, if it's been signed by a certificate authority and that the certificate authority's certificate is in the queue manager's key store. Now you can also, as well as checking that the certificate is valid and trusted, check that the distinguished name of the certificate matches something that you expect. And the way that you set that up, or one way that you set that up, we'll have a look at another one in a minute, is by using the SSL peer attribute of your channel definition. And that says, if you take the example that we have here, where we've got CN equals client set on the server, that's only going to accept connections on this channel from clients that provide a certificate where the distinguished name has the common name set to client. So it filters connections and only allows ones in that match the distinguished name that's specified in the SSL peer value. There is a slightly better way of doing that, filtering on the distinguished name, and that's by using channel authentication records. Now, if you're familiar with MQ, you may already be using channel authentication records because they're not specific to TLS. They're rules that you can specify for connections, any connections that come into your queue manager. And they're essentially filter connections based on attributes in the rule. So you can allow connections or block connections based on whether they match a particular channel authentication rule. And for connections that are allowed, you can assign a user ID to those connections, and that user ID will then be used from then on for everything such as the authorization checks that take place on any operations that that connection performs from then on. You can also do things such as mandating that a user ID and a password is provided by clients that make a connection on a particular channel. Regarding TLS specifically and its interaction with channel authentication records, what you can do is very similarly to what we saw in the channel definition. You can use the channel authentication record to match a specific distinguished name on a certificate that is provided by a client or a queue manager that connects into your queue manager. You can filter on either the distinguished name or of the client certificate itself or of the certificate issuer, so the certificate of the certification authority that created the client certificate. And in this example, we've actually got both of them specified. And once you've done that, once you've actually once you've got a certificate that has been provided on a connection that actually matches this record, what you can do is to then map that connection to a specific user ID. So we're using the MCA user attribute in this case to set a certain user ID for that connection. There's a number of combinations that you can do with a channel authentication record. And that's just one example there that we've got on this slide. But that's a more flexible way of mapping your connections that come into the queue manager with TLS to a specific user and allowing and blocking connections that use TLS based on the distinguished names of the certificates that are provided. It's a bit more flexible than setting the SSL peer value on your channel definition. One thing I'll mention as well while we're talking about certificates is that MQ does support HSMs. So that is a special type of hardware that securely stores your certificates and private keys so that they can't be accessed by anyone that shouldn't be accessing your very private data. These devices normally conform to the PKCS11 standard, and MQ is able to talk to them if they do support PKCS11. Now, the way you configure that in MQ on distributed systems is by using the SSL crip attribute on the queue manager definition. And in that attribute, you set a string that comprises of actually several bits of data. So it's a slightly obscure string. It is documented exactly in the documentation what you need to set in there, but it comprises of various things such as the DLL to access your PKCS11 device, the token for the device that you want to access, and also the PIN, I think, for accessing the device, as well as maybe one or two other things. Of course, if you're using MQ and ZOS, then your Z hardware has access to your Crypto Express cards, which provide a similar function as well as more. And if you're using Crypto Express cards to store your certificates for use with MQ and ZOS, then there's actually nothing that you need to do in your queue manager to configure that, because MQ just accesses the RACF keyring, and it's RACF that deals with where the actual data is stored. So now that we've kind of introduced how to use TLS for both encryption and authentication on your MQ channels, let's have a look at some of the more recent enhancements that we've had in MQ that have to do with TLS, because there have been a few. One really good thing is that we now support TLS 1.3, which is the latest version of TLS. There have been obviously a number of versions of TLS and SSL over the years. The older ones are now disabled by default in MQ because they're not considered secure anymore. So you won't be able to use by default SSL v3 or TLS 1. TLS 1.2 is still supported and enabled by default in MQ. And if you have a new queue manager, you'll also be able to use TLS 1.3. We did roll out TLS 1.3 gradually across the different platforms and environments that you can use MQ in. By now, but the most recent version of MQ is now supported on all platforms and queue managers themselves. So communication between two queue managers and also between clients running in different environments and a queue manager. And along with TLS 1.3 comes 5 new Cipher specs, which is good because a lot of the older Cipher specs that were available in MQ previously have now been deprecated because of the many vulnerabilities that have been discovered recently that I talked about. You can enable and disable TLS explicitly in MQ using the allow TLS v13 property, which you either set in the QM-ini file undistributed or the qm.ini file undistributed or the QM-ini dataset on ZOS. 2 bits to talk about on that point. I haven't talked about the QM-ini dataset before, so that might be something that is new to a lot of you if you're familiar to MQ. That's because it's only been added quite recently, and it's been added to allow you to specify configurations such as this for your queue manager. So it allows you to set things like this TLS v13 property, which is very similar to the way you would do it on distributed. And it's just a data set that behaves on ZOS pretty much exactly the same as the qm.ini file does on distributed. The other thing to say is, why would you want to enable or disable TLS 1.3? Well, TLS 1.3 does prevent you from using some other features if it's enabled. So SSL 3, for example, won't coexist at all with TLS 1.3. So if you're using some deprecated Cipher specs or deprecated protocols, then you will have to turn off TLS 1.3 because they just don't coexist on the same queue manager. Something else that we've added fairly recently in MQ is the ability to specify alias Cipher specs. So I did say earlier in the presentation when I was introducing the concept of Cipher specs and how you specify them on a channel using the SSL Cipher attribute, I said that you needed to specify the same Cipher spec on both ends. And that's obviously true that both ends of the channel need to agree on the same Cipher spec to use so that they understand each other. But if you have to specify exactly the same Cipher specs on both ends of the channel, then that obviously can get a little bit complicated when you need to change the Cipher spec that's in use because maybe the one that you're using currently has been deprecated or as a result of being insecure. You now need to change to a more secure Cipher. If you need to coordinate changing both ends, then that's obviously a more difficult process than if you have the ability to specify a alias Cipher spec, such as one of these, which contains a number of different ciphers. Now, this is more like how your browser, for example, works when it connects to a web server. You don't say that you want your browser to use a specific TLS cipher when it connects to a server. The browser and the server can both support a range of ciphers for the TLS connection, and they then agree on which one, the most secure one that's going to be used for the connection during the TLS handshake. And that's generally what these new alias Cipher specs will do for MQ as well. So what you can do is to select one of these 5 new alias Cipher specs that we have. So the any Cipher spec will, as you can guess, let MQ use any enabled TLS cipher, and the connection will negotiate which is the most secure that's supported and enabled by both ends of the connection, and we'll use that one for the rest of the TLS session. It is recommended that you set the more fine-grained version. So, for example, the specific Cipher specs that you want to use on the client, and to set the Cipher spec, the alias Cipher spec that allows a range of protocols to be used on the server. So if you think about it, you want the client to connect into the server and saying that it wants to use a particular Cipher, and the server can then say, yes, that is one that is allowed by me. I allow a range of ciphers to be used, and that one is one of the ones that I support and is enabled. And so we can agree to use that one that's proposed by the client. That's the easiest way to get this to work. The other way around, if you were to set the alias cipher spec on the client, then you do open up the possibility that the client will ask the server for a number of ciphers when it connects in doing the TLS handshake, and the server might be configured with something that isn't compatible with the client. So the reason that these alias cipher specs are good is that if you want to change the ciphers that you use on your channels at any point to use a more secure cipher, then it makes it a lot easier, because you don't need to coordinate changing the both ends of the channel anymore. You don't need to coordinate changing the cipher spec on both ends of the channel at the same time. So that should make migration to higher protocols and more secure ciphers easier from now on, once you start using alias cipher specs on your channels. So the ones that we have, I already talked about the any one. We have any TLS 1.2 and any TLS 1.3, which, as you can guess, lets the channel use any version of TLS 1.2 or any version of, sorry, any cipher that is usable with TLS 1.2, or any cipher that can be used with TLS 1.3. Or we've got the any TLS 1.2 or higher cipher, which, as you can guess, will allow any TLS 1.2 or TLS 1.3 ciphers to be used. Or the newest one is any TLS 1.3 or higher, which, again, as you can probably guess, is any TLS 1.3 ciphers or any future ciphers that come along with future versions of TLS. Now, I did mention previously that with deprecated cipher specs, there is a way to re-enable them in the queue manager. You might also want to have a bit more control over which cipher specs are enabled in your queue manager for when you're using alias cipher specs. And for both of those purposes, there is a way of specifying a custom list of cipher specs in your queue manager, which will be the enabled ones on the queue manager at that time. And even if you're using an alias cipher specs, then the actual one that gets negotiated will be one of the ones that you specify in this attribute, which specifies the allowed cipher specs for the queue manager. It's also an ordered list that you can specify. So you can, if you like, change the order of priority of cipher specs that are used in a TLS handshake. By default, MQ does have a default list of enabled cipher specs and priorities for those cipher specs. So which ones it considers more secure than the other, and obviously you will negotiate the most secure one for a connection. You can change that, and you can change which ones are enabled by using this allowed cipher specs attribute that you can either put in the QMini file on distributed or the QMini dataset on ZOS. That's also a new feature that has been added within the last couple of years, I think, on MQ. Now, something else to talk about is server name indication. You may already know a lot about this, being on a security stream. If you're familiar with TLS, you may very well know about it. It's an extension to the TLS protocol that allows the client to send a little bit of data right at the beginning of the TLS handshake that indicates what service it requires. So normally this is used by your browser, for example, to indicate the host name to the web server of which host it actually wants to connect to, and then the web server knows which certificate that it needs to provide to your browser. If the server is hosting several websites, for example. Now, MQ uses the SNI extension for exactly that purpose, but it has actually repurposed it in a way because the data that is or was normally sent in it isn't the host name, it's something else. So let's introduce how you configure your queue manager to use certificates to start off with. So you will, on a particular queue manager, have a certificate that is essentially the queue manager certificate, and that's stored in the key store that's used by the queue manager. You configure the label of that certificate for the queue manager using the cert label attribute of the queue manager definition. And for any connections into the queue manager that don't have any definitions for any other certificate that should be picked up, then that's a certificate that will be provided to the client on the TLS handshake. Now, there is a way, has been a way in MQ for several years now to specify on a particular channel definition that you want that channel to use a different label for the certificate that's presented to the client when there's a connection that starts into the queue manager on that channel. There's a cert label attribute on the channel definition as well that specifies the label to be used for that particular channel. Now, in order for that to work, MQ needs to know right at the beginning of the connection, the TLS connection into MQ, what the channel is that's going to that the client wants to use. And in order for that to work, the client will send the channel name, or a mangled version of the channel name, as you can see in this example, in the SNI information right at the start of the TLS connection. Now, that works very well in MQ, but if you have something in between the two queue managers, or in between the client and the queue managers, that is expecting the SNI to be set to something else, such as the host name, then it'll get a little bit confused when he sees a channel name instead of the host name. And that is the situation if you're connecting into something like OpenShift, because the OpenShift router, when it gets a connection, expects the SNI to be set to the host name, and then it uses the host name in order to route that connection to the queue manager that's running inside of OpenShift. So in order to allow you to connect into queue managers in this environment, in a recent version of MQ, we've added the ability to change the SNI configuration. So you can now choose whether you want the SNI to be set to the channel name, as you saw in the previous slide, or to the host name, which is what you see on this slide. We'll be connecting into OpenShift. That's a new property in the QMini file transport security stanza. You can either set it to host name or channel. This isn't really a new enhancement in MQ, but it's something that's worth talking about nonetheless. And it's something that we've actually improved the documentation on quite recently. So in a way, that's an enhancement, and that's why I'm putting it in this section. So MQ has been able to be used with AT-TLS on ZOS for quite a while now. Application Transparent TLS, or AT-TLS, is a feature on ZOS that encrypts the connection to or from a queue manager running on ZOS without MQ actually being aware that TLS is being used at all. Now, there are maybe some benefits to using this. You might want to have your TLS configuration on the system for AT-TLS rather than in MQ itself. There might be some performance benefits. If you want to look at the performance comparisons between using TLS in MQ and AT-TLS, then you can look at the MP16 support pack, the performance support pack for MQ and ZOS. We do have some fairly detailed comparisons there. But the thing to note here is that for a little while now, we have said that you can use AT-TLS with MQ, but you should probably only use it between your ZOS queue managers, because of course AT-TLS is a ZOS concept, and if you're connecting out to a distributed queue manager that obviously can't use TLS, then you need to have your MQ configuration somehow be able to talk to that TLS connection that is not controlled by MQ on the ZOS end. So you can absolutely use AT-TLS between your ZOS queue managers. That's been the case for a number of years, and a number of people are doing so already, and more seem to be wanting to do so at the moment. What we've done now is to document and say that we do support configurations between distributed queue managers and ZOS queue managers that are using ATTLS. So you can use, you can have your ZOS queue manager configured for ATTLS, and as long as you configure your distributed queue manager or an application that's running on distributed platform and connecting into your ZOS queue manager, as long as you configure those to have the right Cipher specs, for example, so that it's compatible with what's happening on the ATTLS side and ZOS, then you can run in that configuration and you are supported in doing so. It's important to remember that there are some restrictions here, because if you're configuring your MQ connection to use TLS in MQ itself, then MQ can do some things based on the certificates that are received during the TLS handshake. For example, we saw an example of that in setting up channel authentication rules to filter based on the peer certificate. If MQ on ZOS has no knowledge of the fact that TLS is in use, or what the certificates that were exchanged during the connection, for example, then you're not able to do those things in MQ. So you won't be able to set up your MQ configuration to excuse me, you won't be able to set up your MQ configuration to filter connections based on things such as the distinguishing name of the peer certificate, because MQ doesn't get to see the peer certificate if ATTLS is being used. And there's also reasons that you can't use ATTLS with clusters that span ZOS and distributed, because obviously if your cluster channel definition is when they're set up using TLS, then that channel isn't going to be usable on ZOS, where the queue manager doesn't actually need to encrypt the connection with TLS. So you've got different requirements on each end of the connection because of ATTLS being used on one end and the other, and not on the other. But it's something to look at if you're interested in using ATTLS with the MQ on ZOS queue manager. So another thing that isn't really fit into the recent enhancement of MQ, but I thought I should mention it anyway at this point, is if you're using TLS on your connections between your MQ endpoints, whether it's a queue manager to queue manager connection or an MQ client to a queue manager connection, then if you're going over the internet, or if you're doing anything which involves going through a firewall to go between different networks, then you might want to consider using MQ Internet Pass-Through. And this is a optional component of MQ these days. It used to be a support pack, but it was integrated into MQ late in the MQ 9.1, the last version of MQ. And what it does is to allow you to perform a number of things in an MQ connection, actually, but as we're specifically talking about TLS in this session, what you can do with it regarding TLS is to encrypt or decrypt MQ connections at some point between the MQ endpoints without those connections being aware at all that anything is going on. So you could, for example, as we have on this slide, have MQ Internet Pass-Through encrypting a plain text connection before it gets sent over the internet, so that it's encrypted with TLS wireless on the internet for security, but then decrypting it as soon as it gets back into your secure network. And in this case, the queue managers on both ends don't actually know that TLS is being used anywhere between the connections. You can, of course, do other things. You can decrypt and re-encrypt a connection. For example, in a DMZ, that's a very common use case for MQ Internet Pass-Through. It then provides a break in the TLS session in your DMZ. And that's something that a number of customers have as a requirement for connections that go in or out of their organization when they're going to the internet or to different network. It also can be used to push out the TLS configuration and the checks on the connections that are coming into your network out to your DMZ, or at least closer to where the connections are coming in, rather than those checks all being performed on the queue manager itself. So there's a number of reasons that you might want to consider using MQ Internet Pass-Through with your TLS connections if your connections are passing through different networks along the way between your MQ endpoints. So I did actually go through that a little bit quicker than I was expecting. So I'm sorry for finishing a little bit early. But But that is all that I had to say about securing your TLS channels with MQ. So if you have any questions, I am very happy to take them now.
Thanks very much, Gwydion. If you have questions, please put your messages in the chat. I think we can probably unmute people if they wish as well. Sue, can we arrange that people can unmute themselves?
Yep, done.
Excellent. Okay. So anyone has any questions? I'm sure there must be people who haven't followed all that. Speaking myself as somebody who doesn't know MQ but knows a bit about TLS, I've learned a bit. Sorry, here we go.
Okay, external CAs, are they preloaded in the key store? I think there is a way for one of the commands, the gskit commands that MQ on distributed CUM supplies with to create some CAs and to pre-populate your key store with some external CAs. But of course, you want to have a good control of what you actually trust in your organization, what certificates that you trust. So you probably want to, even if you're able to pre-populate them in your key store, then you want to at least make sure that everything in there is exactly what you want in there. So I think it's a yes, but obviously take note of what he puts in there and maybe remove some or add some as you see fit.
Anybody else come with any questions? Hello? Well, it seems that everybody has fully understood your session, Gwydion.
Well, that's excellent.
It is, isn't it? Yes, absolutely. So if everybody's really happy with Gwydion's session, then I expect you to give very good feedback. I'm supposed to remind you that for one of these questions, the answer is the middle one, not the high one. So that's the second question there, isn't it? What's the length of the presentation about right? So everybody else, if you like Gwydion's session, please give him a good score. I'll remind you once more that there are charities and a raffle. So if you take part in the raffle, we are supporting 2 excellent charities this year. And if there's no more, then I think we should say a very big thank you to Gwydion for the effort he's put in there and for the work done on MQ, keeping our system secure. And we have a question from Beth. No, we have a thank you from Beth.
Thank you.
Okay, so thank you, and I can tell everybody else that the Enterprise Working Group next session will be tomorrow. I think we're starting with a session at 10:30, which will be from Mark Wilson. Some of you may have heard of Mark Wilson, who's our great chairman for GSE, who's worked in security for many decades. Is there anything else I'm missing there, Sue? Something I need to tell everybody?
No, I think we've covered it.
I think we're done. Okay. So don't forget your feedback. Don't forget the next session. There are, of course, lots of other GSE sessions. You've only got to look at the agenda, and there are sessions which you can attend in lots and lots of other streams.
Oh, I would just suggest anybody who fancies it tonight, there is the quiz.
All right, yes, quiz tonight.
Which is quite worth going to. Anyway, apart from that, thank you very much.
yes, thank you very much, everyone. And maybe we'll see you tomorrow.
Okay,
Goodbye.
thank you, everyone.
Thank